Okay, so here we have a problem about bacteria, and it says a population of bacteria doubles every hour. Well, right there, that's going to tell us this is an exponential model because it's doubling every hour. So you could think about that, spend some time coming up with some ordered pairs, which we'll do at the end. But if the culture started with 10 bacteria, graph the population as a function of time. Okay, so we're going to think about our model. Oh, y equals a naught e to the kt. That's the model that we have for our exponential growth or decay. Okay, so what's happening? Well, we're starting with 10. That's going to be a naught, the initial amount. And then it says the bacteria doubles every hour. We're going to say hour is the time, t. And so we have the time being in 1 hour, and it's going to double our bacteria. Okay, so a point in time. We start out with 10 bacteria. Okay, that's like x and y. Starting out with 0 time. Okay, I should put this as a t. How's that? Time. 0 time has gone by. We've got 10 bacteria. Okay, an hour goes by, and now we have 20. 2 hours go by, and now we have 40. Okay, so you can kind of see what's happening there. And we'll use that to graph things. But we're going to come up with the formula for it. Okay, so we know a naught. We know a point in time. We know that when t is 1, the y is going to be 20. Okay, the output is 20. Okay, so let's use that information. Now you might be saying, okay, I'm lost. You can go back and review this, but we're trying to find k is what we want to do. We need to find k because we don't know that constant. We do know it's positive because it's doubling, but we don't know what the constant is. So we know that when there's 20 bacteria, the a naught was 10, and then we had e to the k times 1. We'll put it like that because our time was 1 hour. So this is just a piece of data that we know. And you can say, well, why didn't you use the 2 and 40? You could do that, but probably it's easier to use 1. Okay, so first thing we would do is divide by 10. So we'd get 2 equals e to the k power, and then we're going to just either convert it to a natural log or think about taking the natural log of both sides. That's what we did in previous equations. We said natural log it. Now I'm going to write this one out so you can see it. But then you get the natural log of 2 equals k. Because remember, this base and this argument are the same. That's that property 3. And it just equals that k value. It's one of the inverse properties. Okay, now that we know what k is, we can do a little bit with our formula. We can say y equals, we know the initial amount, so we know the 10, e to the natural log of 2, which is just a number, by the way, times t. Okay. Now, I'm going to write this a little bit differently so you can see it. 10 e to the natural log of 2 to the power of t. Now this right here, we're going to use the other inverse property. So you might have to go back and hopefully you'll have a sheet that has the logarithmic properties written down. But it says that that's just going to be 2. So now I get my model to say y equals 10 times 2 to the power of t. Okay, and now I can think about graphing things. Now, how is this going to work? Well, I'm not going to go back in time, for one thing. So I'm going to be starting at 0 time. And then I'm going to have an hour, 2 hours, 3 hours, 4 hours, maybe 5 hours. And then I'm going to have a pretty, I don't know, small, large scale. I'm going to change my scale here. I'm going to count by 20s. So 20, 40, 60, 80, 100, 120, 140. We'll just write it here. And we're counting by 20s. Now, when you change your scale, you do need to mark it. You don't have to put all the numbers in. I probably have too many. Usually they space it out, so I'll just put them all in. Okay. And then this is going to allow us to get a graph. So we already had a table of values going, right? So we said when there was 0, at time 0, by the way, this is time, and this is the amount of bacteria. You should always label your axes when you do these because, you know, we want to say this is specific for what's going on in this situation. So we had 10 bacteria at 0 time. An hour went by, and then we had 20. 2 hours went by, and now we have 40. 3 hours go by, and now we have 80. Because you're doubling it, right? Now you can use this formula, but it's the same thing as just thinking, okay, 3 double the 40. 4 hours, okay, now I'm at 160. Okay, so now I'm off the charts. Should have gone a little bit higher. But you can see, wow, that's going up quickly. That's an exponential function. Okay, so we get this information and we graph it so we can identify what type of function it is. But we already knew it was an exponential function. Okay, so that's that one.